Hi everyone, my name is Alima and today we'll talk about the magnetic field of the bar magnet. We'll talk about the experiment, the computational model used, and the results. So the purpose of this lab is to measure and observe the distance dependence of the magnetic field due to a small bar magnet. To do so, we will use two fundamental principles, the Biot-Savart law that stated that the magnetic field is equal to this equation and the distance dependence equation. The result from this experiment was that the distance dependence was negative 2.7559 and the magnetic moment was 4.19 am squared. So for this experiment, the first step was to zero out the sensor in the x-axis. Then we had to locate the magnetic sensor on the phone. That's why we use the yellow tape, as you can see on the image, having the cross and the red marker was indicating the sensor on the phone. We had to record the distance from the sensor for several Z components and put those data in a spreadsheet. For the data, I recorded different distances for different R20, R70, and R120. As you can see on your left, you have the formula that relate the magnetic field to the distance dependence, which is the slope. So from the graph, we found that the slope was equal to negative 2.7559. And for the magnetic moment, we used ln k equal to negative 13.99, and from then we deduced the dipole moment that is equal to 4.199. For the computational model, u naught over pi, which is equal to 1 10 to the minus 7, was put into the code through script. The dipole moment magnitude was calculated, and the magnetic field was calculated through a function that you can see here. For the magnetic field magnitude at 45 degrees, which is represented by the purple arrow, we have two different answers for the computational model and the experiment, which can be explained by interferences in the experiment because there wasn't only the magnetic field of the bar magnet. The orange arrow represent the parallel magnetic field, and the blue one the perpendicular one. So as a conclusion, what if you had then oriented your experiment to compensate for magnetic north? Well, the measurements that we will have will account on each axis for the Hertz and the bar magnetic field. And what if you were to stick to two identical magnets together, then I would expect my measurement to double because of superposition of the magnetic field. Thank you.